Hello, everyone. Can you folks hear me okay? Okay, cool. So, welcome to the session. So this session is for all of those who want to do Python machine learning scenarios. And I'm going to show you some really cool ways of how you can use Azure Functions to do that. A little bit about me. I'm Sonia. I am a program manager in the Azure Functions team. And one of my main goals is to make machine learning and Python scenarios successful on functions. So I do want to make sure that the content I present is valuable to all of you. So just by a show of hands, how many of you are aware of what serverless is? OK, awesome. So most of you are aware, but just for the ones who are curious, it's three main things. Abstraction from off the server, so you don't have to worry about the infrastructure your code is running on. Second is the instant event-driven scale, so your workloads scale in and out depending on your incoming traffic. And finally, pay-per-use, so you are billed based on your usage. Azure Functions. Anybody here uses Azure Functions already or is interested? OK, so let me talk a little bit about what Azure Functions is. So it's an event-based serverless compute experience. And looking at the programming paradigm that it uses, it's three main components. The first thing you could think about is the code or your business logic that you want to write, which is essentially the function app. The second thing is the events that happen in your architectures that would invoke that function app, which are called as triggers. Some common examples of triggers are HTTP, timer, service bus, and so on. And finally, the third component is the data sources that your code might want to connect to, and those are called bindings. So with Azure Functions, the triggers and bindings support is something we provide out of the box, and so you don't have to worry about the SDK and the API implementation details of the services that you connect to. You can write your functions in any languages, any language of your choice. And you can host them on two plans. We have primarily the consumption plan, which is our basic plan. And second, we have the premium plan, which has a little more premium hardware. It allows you VNet connectivity and gives you more memory and CPU limits. OK, machine learning. Getting to what we are here for, right? We all know, we all kind of have done machine learning some way or the other or are interested in doing it. So what is machine learning? So machine learning is basically examining vast amounts of data and recognizing patterns in that data to generate code that then identifies similar patterns in brand new data, right? Looking a little bit at the process of machine learning, we start with a vast data set, or large data set, and then we apply some data pre-processing modules on that data set to come up with some prepared data. The main objective of this stage is to come up with data which is reliable and of higher quality that qualifies it to train a model. So this is the data processing stage. We want to make sure the data here has no duplicates, abnormalities, or anomalies. The next stage is where we will apply some machine learning algorithms on this prepared data to come up with that piece of code, which is able to recognize these patterns. That is nothing but the candidate model. And this stage is called the model training stage, right? So the first two stages are iterative, and we continue to do this until we have a high level of confidence that we have a great model, and now we are ready. We had great data, we have great model, and now we are ready to go ahead. So the next stage is the model deployment stage, where you actually want to deploy this model to production to see how it performs and how effective it is. So primarily, the data processing and model training would be done by a data scientist. And the model deployment is usually done by an application developer. So now I do want to talk about two types of data here. One is the training data that we use to come up with the model, to build the model. And the other is test data that we use to test how our model is performing once it's deployed to production. And just like we have to do pre-processing for the data that we start with, we also have to process the test data to make sure that it is consumable by the model. That is what the line from data processing to application developer means. And there are these two scenarios can be automated with functions. Let's see how. For the data processing one, it seems pretty intuitive knowing and talking about what functions is. Say we have some test data that is dropped to a blob storage. That can be a trigger to a function app that actually processes that data and then outputs it to, say, a Cosmos DB. I'm going to talk more about the model deployment scenarios. So when a model is ready, it needs to be deployed to production in conjunction with some inferencing code. Now, this inferencing code is usually written in the same language that was used to train the model. Right? I'm going to now show you a demo of how you can use Azure Functions to deploy this inferencing with the model. Okay, so I already have a trained ML model that classifies a dog from a cat. And I have written the inferencing logic as a function app using VS Code. Let me show you the VS Code experience. I have the Azure Functions extension installed in VS Code. This makes it really easy to get started. So using the command palette, I would just say, Azure Functions create new project. It'll ask me where I want to create it. So I am going to create a new folder. So this is all on my local ecosystem. Name it sample, and create this app. I want to use Python, and I want to use an HTTP trigger template. I'll name it HTTP trigger app, and select the anonymous authorization level. Open in current window. So right now, what it's doing in the background is creating a virtual environment, and it will set up the folder structure of the function app with the basic HTTP trigger in Python. What I have now done is updated this code so that to fit my scenario. So I've added code for the inferencing logic. And let me show you how that looks and all the files that it has. So the name of my function app here is image classification app. And the function name is classify. Init.py is the entry point into the function. It's an HTTP triggered function. It takes an image URL and does some prediction with predict image from URL, which is in the predict.py file. I want you to notice two things here. The first 4 lines of code that are highlighted, they are looking for the path of the model that's located in this file structure. And then this block of code, which is the initialize block, which is basically what it's doing is it's loading the model, building the model graph, and it is caching it in memory to make it available for every subsequent execution. So this is one of the patterns we recommend, because then for every execution, you don't have to do the computation again. So looking at the files now, we have the model file in the folder structure here. The labels.txt is what is used by the inferencing app. And we have the requirements.txt, which basically lists out all the dependencies that my app has. Now, I'm just going to deploy this to the cloud. So I'm going to use command palette, the Azure Functions, deploy to function app. So at this point, it will ask me if I want to create a new function app in Azure and then deploy to it, or just deploy to an existing created function app. So what I've gone ahead and done is created a new function app in Azure and deployed this code to it. That is how easy it was to get a function app up and running in Azure. And more so, in this case, we deployed a trained ML model with inferencing in just a matter of a few clicks. Isn't that awesome? Cool. All right, I do have a few more things to show you. So how many of you have used Azure ML for your model training? OK, I see a few hands here. Awesome. So we've also heard a lot of data scientists use Azure ML for training their models. So what if I told you that there was a way to deploy your model and your inferencing code without leaving your Azure ML ecosystem? Yes, there is one now. So when you train your model in your Azure ML workspace, all you have to do after the model is ready is you will write your inferencing logic and your configuration in your workspace, in the same workspace that you used to train your model. And then you will run a simple command that will package your inferencing code, your model, and all the dependencies it has in a container and publish that container to Azure Container Registry. So what you get for free here is that container also has the functions runtime packaged with it, which makes it possible to deploy the container to functions. Isn't that exciting? OK, cool. Thank you for all those who are excited. OK. OK. A few more details on this. So currently, it supports 3 types of triggers. That is the HTTP, blob, and service bus trigger. And it deploys the container to Azure Functions Premium Plan. Like I mentioned before, Premium Plan has premium hardware. It has advanced capabilities, which are often the requirements for machine learning scenarios. We often need higher memory and higher CPU for machine learning. So it's really a great fit to deploy it to the premium plan. Just as an example, in Premium, we give you 14 GB of memory per instance, as opposed to 1.5 GB in consumption. OK, I am going to talk about yet another way how you could do your model deployments. So if you've noticed closely, the first 2 approaches that I spoke about, they all were packaging the model and the inferencing code together. But in this one, this approach is going to be slightly different. I'm going to show you a demo where you can decouple your model and inferencing logic deployments. OK, so what you are going to see here is the same code that we saw in the first demo. But I do want you to notice some differences based on what we already saw. Do you see a difference in the script path? So it's now reading from an environment variable called user data home to locate the model files. Also, in the folder structure, you notice that there are no model files here. So what I've done is I've gone to the portal and created a function app. So classifier app is my function app, and that is the associated storage account. I've also deployed this code to my function app here. And what I've done is in the storage account, I've created a file share by the name model storage. And this is where I've uploaded my files, the model files. Now, since the function app is up and running, let's see what happens if I invoke the function with an image URL of a cat. And the prediction logic worked, and it returned that it was a cat. So it actually, inferencing logic returned us a response that this image was that of a cat. Awesome. But how did it know where to look for the model files? I'll show you how. If you go to the function app configuration settings, I have set 3 configurations. The first one is the content Azure file connection string, which is basically the connection string of the storage account that you had your model files uploaded in. You can get it easily from the storage account. The second setting is the website content share. So this is the file share that I created, the name of the file share in that storage account. And finally, there is the user data mount enabled, which is supposed to be 1. Now, since I had these configuration settings already, the function app was able to load the model files from Azure Files, run the inferencing logic, and send us back a response. Now, consider a scenario where you have a new version of the model that needs to be deployed. It's easy. You could just go to your storage account and upload the model in the existing file share. This will overwrite your previous model, and you need to restart your function app. But the more recommended way would be to create a new file share. Say, I'm calling it model storage v2. and uploading your model files in that storage, in that file share. Going back to the function app, making sure it can use that file share, I'm going to update the website content share to point to model storage v2. When I save this, the function app restarts automatically, and the new setting is in effect. So this is how you will be able to version your models and upload them without having to change or redeploy your inferencing logic or your function app. There is also two more benefits with it. One, if you want to roll back or roll forward to any version of the model that you have, you can do so easily by just changing an application setting. And as the model grows in size, it will also be keeping it separate from the function app will make sure that your function app deployments remain fast. OK. And that was my last demo. So looking at a few announcements that we have for Ignite, we are announcing support for Python 3.7 on the functions runtime. So you can now use Python 3.7 to build your apps locally and deploy them to Azure Functions. Another thing that we have released is the server-side build capability. What that means is, if you had a function app which had OS native dependencies, you needed to have Docker installed locally. And that would spin up a container and install those dependencies. You would have to do that before you could deploy to Azure. But with the server-side build capability, we are doing it on the platform side and managing all that for you. All you have to do is just list out your dependencies in the requirements.txt file. So you can publish your code, or you can publish a function app as code or container to Azure Functions, and it will run in the Linux ecosystem. And our two main code paths is Visual Studio Code. You can use that experience, which we saw today, or the Azure Functions core tools. There are two more callouts here. The portal experience for Python 3.7 Create is coming up soon. And the Azure ML and the Azure Files demos that I showed you, you'll be able to work with them and play with them sometime this month. OK. Finally, I do want to say, if there was one slide I'd ask you to take a picture of, that would be this one. So this one has some resources to get started with Python and machine learning and functions. And I also have our Twitter handles here. There's one thing I want to talk about, apart from the session evaluation, is the survey. So it would really help us to know where you are in your journey, in your ML scenario journey, and how you already use Azure Functions if you do, what you would like to see more in Azure Functions. So please, it will be really helpful for us if you can fill out the survey and provide us the information. Finally, there are a few sessions coming up. There's one later today and one tomorrow. The bottom two are the AKS ones. These are all the sessions that our team did over at Ignite. So the AKS one and the serverless technology one are coming up today and later tomorrow. Finally, I do want to thank you for your time. And I just hope this session was valuable and it provided some information to you and it excited you to go and try out Azure Functions with machine learning scenarios. If you have any questions, I'll be at the Azure Functions booth. And I look forward to hearing from you. I'll be at the booth until the end of the day. Thank you.